The Solar System, an in-depth exploration. The Solar System is a vast and dynamic collection of celestial bodies that orbit around our Sun, creating an intricate web of gravitational relationships. At its core, it consists of the Sun, 8 planets, their moons, dwarf planets, comets, asteroids, meteoroids, and an array of other smaller bodies, all of which play distinct roles within this cosmic network. This complex system is situated within the larger Milky Way galaxy, and it serves as the focal point for much of modern astronomy, space exploration, and our understanding of the universe. Gaining a deep understanding of the nature and structure of the solar system is essential, not only for comprehending Earth's place in the cosmos, but also for investigating the potential for life beyond our planet. It also opens a window into the forces that govern the behavior of all objects in space, which are crucial for understanding fundamental aspects of physics and space science. At the heart of this system is the Sun, a massive star composed primarily of hydrogen and helium, which generates energy through the process of nuclear fusion. The Sun's immense gravitational pull is what keeps all of the other objects in the solar system in orbit, from the smallest meteoroids to the largest gas giants, such as Jupiter and Saturn. These gravitational forces are integral to the solar system's structure, dictating the orbital paths of the planets, moons, and other objects. The Sun's radiation and gravity also provide the essential conditions needed for the existence of life on Earth, warming our planet and driving important processes like weather patterns, ocean currents, and photosynthesis. In addition, the Sun influences the dynamics of the entire solar system, shaping everything from the behavior of comets to the trajectories of spacecraft sent on exploratory missions. The solar system spans staggering distances, with each of the 8 planets orbiting the Sun at varying speeds and distances. The innermost planets, Mercury, Venus, Earth, and Mars, are rocky and terrestrial, while the outer planets, Jupiter, Saturn, Uranus, and Neptune, are predominantly made up of gas and ice, with the 2 largest being gas giants. In addition to the planets, their numerous moons, along with countless comets and asteroids, add layers of complexity to the system. The outermost regions of the solar system are marked by the Kuiper Belt, a vast region that lies beyond Neptune, and is filled with icy bodies and dwarf planets like Pluto. These objects are remnants from the early solar system, providing a snapshot of its formation and early evolution. Beyond the Kuiper Belt lies the Oort cloud, an enigmatic, distant spherical shell of icy bodies that is believed to mark the farthest boundary of the solar system. The Sun, the core of the solar system. The Sun is by far the largest and most dominant object in the solar system, holding more than 99.8% of the system's total mass. It is a massive ball of hot, glowing gases composed primarily of hydrogen, about 74%, and helium, about 24%, with trace amounts of heavier elements like oxygen, carbon, neon, and iron. The Sun has a diameter of approximately 1.4 million kilometers, which makes it roughly 109 times the diameter of Earth. To put this into perspective, if the Sun were hollow, about 1.3 million Earths could fit inside it. Its immense gravity is the force that governs the motion of all the planets, moons, comets, asteroids, and other objects within the solar system, ensuring they all remain in their respective orbits. At the heart of the Sun lies a process called nuclear fusion, which is responsible for its energy production. In the Sun's core, where temperatures soar to around 15 million degrees Celsius, hydrogen atoms are fused together under extreme pressure to form helium. This fusion process releases vast amounts of energy, primarily in the form of light and heat. The energy produced by nuclear fusion moves outward from the core through several layers of the Sun, including the radiative zone and convective zone, before finally reaching the surface, or photosphere. From there, it radiates into space as electromagnetic radiation, including visible light, ultraviolet rays, and infrared radiation. This energy is what sustains life on Earth, providing the warmth, light, and energy needed for everything from plant photosynthesis to the weather systems that govern the planet. The Sun's energy output is not only crucial for life on Earth but also has far-reaching effects throughout the entire solar system. The Sun creates the solar wind, a continuous stream of charged particles, mainly electrons and protons, that flows outward from the Sun at speeds of up to 900 kilometers per second. This solar wind interacts with the magnetic fields of planets, moons, and other objects, creating various phenomena. For example, when the solar wind reaches Earth's magnetic field, it causes beautiful auroras, also known as the northern and southern lights, which are displays of colorful lights in the sky. The solar wind also plays a role in shaping the atmospheres of planets, and in some cases, it can even strip away the atmosphere of a planet over time, as seen with Mars. In addition to its gravitational pull and energy output, the Sun's magnetic field is also a significant influence on the solar system. The Sun's magnetic field is generated by the motion of charged particles in its interior and extends far beyond the Sun itself, forming what is known as the heliosphere. The heliosphere is a bubble-like region of space dominated by the solar wind and the Sun's magnetic field, extending well beyond the orbit of Pluto. The boundaries of the heliosphere mark the edge of the Sun's influence, and beyond it, the interstellar medium takes over. The solar wind and magnetic field shape the space weather environment, affecting everything from satellite communications to the health of astronauts in space. The Sun's activity is not constant, it follows an approximately 11-year cycle of solar activity, known as the solar cycle. During this cycle, the number of sunspots, dark, cooler areas on the Sun's surface, increases and decreases. Sunspots are regions of intense magnetic activity, and their appearance is often linked to solar flares and coronal mass ejections, CMEs, which are violent bursts of solar wind and magnetic fields that can have significant impacts on Earth's space weather. These eruptions can cause geomagnetic storms that disrupt satellite communications, navigation systems, and power grids, and they also pose a radiation risk to astronauts and high-altitude airline flights. Beyond its influence on Earth and the other planets, the Sun also plays a key role in the long-term evolution of the solar system. Over the course of billions of years, the Sun will continue to burn through its hydrogen fuel, gradually transitioning to a red giant phase. As it expands, it will engulf the inner planets, including Mercury, Venus, and possibly Earth, before eventually shedding its outer layers and leaving behind a dense core known as a white dwarf. Mercury, the closest planet to the Sun. Mercury, the smallest planet in the solar system, holds the distinction of being the closest planet to the Sun. With a diameter of about 4,880 kilometers, it is only slightly larger than the Moon. Despite its small size, Mercury is a fascinating and extreme world. Its proximity to the Sun results in a number of unique and harsh environmental conditions. However, unlike Earth, Mercury does not possess a thick atmosphere, which leads to extreme temperature fluctuations on its surface. The lack of an atmosphere means there is no insulating layer to retain heat, causing temperatures to swing wildly. During the day, when the planet faces the Sun, temperatures can soar to nearly 430 degrees Celsius, 800 degrees Fahrenheit, making the surface unbearably hot. On the flip side, at night, the absence of an atmosphere to trap warmth results in temperatures plummeting to a chilling -180 degrees Celsius, -290 degrees Fahrenheit. Despite these extreme temperature swings, Mercury does not remain consistently hot overall due to its inability to retain heat, creating a dramatic contrast between day and night. Mercury's surface is heavily scarred with numerous impact craters, giving it a similar appearance to Earth's moon. The planet's geological features are the result of countless collisions over billions of years, leaving behind craters of varying sizes and depths. In addition to its craters, The surface of Mercury is marked by large, flat plains and deep cliffs, which may have formed as the planet cooled and contracted over time. One of Mercury's most intriguing characteristics is its slow rotation. A single day on Mercury, the time it takes for the planet to rotate once on its axis, lasts 59 Earth days. This is notably longer than its orbital period around the Sun, which is only 88 Earth days. As a result, a single day on Mercury lasts nearly 2/3 as long as a year on the planet. This odd ratio of rotation to orbit means that a person on Mercury would experience very long days and nights, each stretching over the course of several months by Earth standards. In addition to its slow rotation, Mercury's orbit is highly elliptical, meaning its distance from the Sun varies significantly throughout the year. At its closest point, the planet is only 46 million kilometers, 29 million miles, away from the Sun, while at its farthest, it is 70 million kilometers, 43 million miles, away. This variation in distance contributes to the planet's extreme temperatures and unique climate conditions. Despite the inhospitable environment, Mercury remains a subject of great interest for scientists. Venus, Earth's twin Venus, the second planet from the Sun, is often referred to as Earth's twin due to its similar size, mass, and structure. Both planets share a comparable diameter and are composed mainly of rock and metal. However, despite these similarities, Venus is vastly different from Earth in terms of its atmosphere, surface conditions, and overall habitability. While Earth is known for its life-supporting environment, Venus presents a much more hostile and extreme atmosphere, making it one of the most inhospitable planets in the solar system. Venus's thick atmosphere is predominantly made up of carbon dioxide, around 96.5%, with clouds of sulfuric acid that are highly reflective and contribute to the planet's extreme greenhouse effect. This dense atmosphere traps heat, causing temperatures on Venus to soar to around 460 degrees Celsius, 860 degrees Fahrenheit, making it the hottest planet in the solar system, hotter even than Mercury, despite Venus being farther from the Sun. The high temperatures are enough to melt lead and create an environment where nothing could survive. The surface of Venus is also a place of extreme pressure, with atmospheric pressure about 90 times that of Earth's at sea level. This crushing pressure is equivalent to being deep under the ocean on Earth, and it would be lethal to any human or spacecraft attempting to land on the planet. Venus is also plagued by violent winds that can reach speeds of up to 360 km per hour, 224 miles per hour, in some regions, creating storm-like conditions that further add to the planet's hostile environment. Venus is known for its slow and peculiar rotation. While Earth completes one full rotation on its axis in 24 hours, Venus takes 243 Earth days to rotate once. Interestingly, Venus's day is longer than its year, as it only takes 225 Earth days to complete one orbit around the Sun. This means that a single day on Venus lasts almost an entire Venusian year. Adding to the strangeness, Venus rotates in the opposite direction compared to most other planets in the solar system. This means that on Venus, the Sun would rise in the west and set in the east, which is the opposite of what we experience on Earth. In addition to its slow rotation, Venus's axial tilt is almost zero, meaning it has no significant seasons like Earth does. This, combined with the dense cloud cover and thick atmosphere, results in a relatively uniform temperature across the entire planet, with only slight variations between the day and night sides. Earth, the blue planet Earth, is the third planet from the Sun, positioned at an ideal distance that allows it to sustain a diverse array of life forms. It remains the only known planet capable of supporting life in the vast universe, making it unique and special. With a diameter of approximately 12,742 kilometers, Earth is composed of multiple layers, including a solid inner core made of iron and nickel, a thick mantle of semi-solid rock, and a crust that is relatively thin and rocky. These layers interact to create the dynamic processes that shape the planet. The Earth is surrounded by a breathable atmosphere, primarily composed of nitrogen, about 78%, and oxygen, about 21%, with trace amounts of other gases such as carbon dioxide and argon. This atmosphere is essential for the existence of life, protecting the planet from harmful radiation, maintaining a stable temperature, and enabling processes like respiration in living organisms. Without this protective layer, life as we know it would be impossible. Approximately 71% of the Earth's surface is covered by water, mainly in the form of oceans, seas, lakes, and rivers, while the remaining 29% consists of landmasses, including continents and islands. The water cycle plays a critical role in regulating temperatures, supporting plant and animal life, and shaping landscapes. Earth's landmasses feature a vast array of ecosystems, from tropical rainforests and deserts to towering mountain ranges and polar ice caps, all of which contribute to the planet's extraordinary biodiversity. The Earth's climate is carefully regulated by its atmosphere and the distribution of water. This balance allows for the support of life, with rainfall patterns, winds, and ocean currents influencing global weather systems. The planet's climate can vary significantly depending on geographic location, but it generally experiences 4 distinct seasons due to its axial tilt. Earth orbits the Sun once every 365.25 days, during which time the tilt of its axis causes the variation in the intensity and duration of sunlight received by different regions, resulting in the changing seasons of spring, summer, autumn, and winter. Additionally, Earth is accompanied by a natural satellite, the Moon, which has a profound impact on the planet. The Moon's gravitational pull causes tides in the Earth's oceans, influencing marine ecosystems and coastal environments. Its presence also plays a crucial role in stabilizing the tilt of the Earth's axis, which is vital for maintaining the planet's relatively stable climate over long periods of time. This dynamic relationship between Earth and the Moon is one of the many factors that make Earth such a unique and habitable planet in the solar system. Mars, the red planet Mars, the 4th planet from the Sun, is one of the most fascinating bodies in our solar system. Often referred to as the red planet due to its distinct reddish appearance, this hue is caused by the presence of iron oxide, or rust, on its surface. Mars is notably smaller than Earth, with a diameter of approximately 6,779 kilometers, making it about half the size of our planet. Despite its smaller size, Mars has 2 moons, Phobos and Deimos, which are much smaller than Earth's moon. These moons are believed to be captured asteroids, adding to the intrigue surrounding Mars' history and its position in the solar system. The Martian environment is harsh and inhospitable, with a cold and dry atmosphere that is only about 1% as thick as Earth's. The majority of Mars' thin atmosphere is composed of carbon dioxide, with trace amounts of nitrogen and argon. Temperatures on the planet can plunge to extreme lows, making it an unlikely home for life as we know it. However, the planet's surface hosts remarkable geological features that indicate a more dynamic past. Mars is home to Olympus Mons, the largest volcano in the solar system, towering at a height of 22 kilometers, 13.6 miles, which is nearly 3 times the height of Mount Everest. The planet also boasts Valles Marineris, a vast canyon system that stretches over 4,000 kilometers long and reaches depths of up to 7 kilometers. These monumental natural features hint at the planet's tumultuous geological history. One of the most intriguing aspects of Mars is the ongoing scientific inquiry into whether the planet has ever supported life. While Mars today is an arid desert, research suggests that liquid water may have once flowed across its surface in the past. Evidence from Mars rovers and satellites shows signs of ancient riverbeds, minerals that form in water, and polar ice caps that contain water. The possibility that microbial life may have once existed on Mars, or could exist beneath its surface, continues to drive exploration efforts. Jupiter, the giant of the solar system. Jupiter, the fifth planet from the Sun, is not only the largest planet in our solar system, but also a marvel of scientific intrigue. With an impressive diameter of 139,820 kilometers, it is more than 11 times wider than Earth, and it could easily fit over 1,300 Earths inside its vast volume. This gas giant is primarily composed of hydrogen and helium, making it similar in composition to the Sun. However, unlike the Sun, Jupiter does not have enough mass to initiate nuclear fusion and become a star. Its atmosphere is thick and turbulent, filled with clouds of ammonia, methane, and water vapor, which contribute to its dynamic weather patterns. The most iconic feature of Jupiter is the Great Red Spot, a massive, persistent storm that has been raging for at least 400 years. This storm, which is larger than Earth, is a testament to the planet's extreme weather systems. The winds in the Great Red Spot can reach speeds of over 400 kilometers per hour, and its persistence is still a mystery to scientists. The planet's atmosphere is also known for its striking bands of clouds that swirl around the planet, creating a mesmerizing view of alternating light and dark stripes. Jupiter is accompanied by 79 known moons, with the four largest, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, being among the most fascinating celestial bodies in our solar system. These moons were first discovered by Galileo Galilei in 1610, and have been studied extensively ever since. Ganymede, the largest of them all, is even larger than the planet Mercury. Europa, on the other hand, has sparked significant interest because its icy surface may cover an ocean of liquid water beneath, raising the possibility of extraterrestrial life. One of the most remarkable aspects of Jupiter is its immense size and powerful magnetic field. The planet's magnetosphere is so vast that it extends well beyond the orbit of its closest moon, Io. This magnetic field, combined with the planet's strong radiation belts, makes Jupiter a fascinating subject of study for scientists investigating planetary magnetism and radiation environments. Jupiter's rapid rotation is another fascinating characteristic. A day on Jupiter lasts just under 10 hours, making it the fastest rotating planet in the solar system. Despite this rapid rotation, Jupiter's immense mass and strong gravity contribute to its slow movement around the Sun. It takes nearly 12 Earth years for Jupiter to complete one full orbit. This long orbital period means that the planet experiences distinct seasonal changes, although they are less noticeable than on Earth due to Jupiter's lack of a solid surface. In addition to its spectacular size, atmospheric dynamics, and moons, Jupiter also serves as a kind of cosmic shield for the inner solar system. Saturn, the ringed giant Saturn, the sixth planet from the Sun, is one of the most remarkable and awe-inspiring planets in our solar system, primarily known for its breathtaking system of rings. These rings are composed of billions of particles, ranging in size from tiny grains of sand to massive chunks of ice and rock, making Saturn easily recognizable and iconic. Saturn's majestic rings stretch out thousands of kilometers from the planet's surface and are considered one of the most stunning natural features in the universe. The planet itself is primarily composed of hydrogen and helium, typical of gas giants, and has a diameter of about 116,460 kilometers, making it nearly 10 times wider than Earth. Saturn shares many characteristics with its neighbor Jupiter, as both are gas giants, but Saturn is unique in its atmospheric conditions and its system of rings. The planet's atmosphere consists mainly of hydrogen, helium, and trace amounts of other elements, creating a dense, thick cloud layer. These clouds give Saturn its pale yellow hue, caused by the presence of ammonia crystals and other chemicals in its upper atmosphere. The winds on Saturn are incredibly fast, reaching speeds of up to 1,800 kilometers per hour, and the planet experiences extreme temperature variations, with temperatures dropping to about -178 degrees Celsius at its cloud tops. Saturn is also known for its large and diverse collection of moons. It has 83 confirmed moons, with Titan being the largest and most intriguing. Titan, Saturn's largest moon, is notable for its thick atmosphere composed mainly of nitrogen, with methane clouds and lakes covering its surface. This unique atmosphere makes Titan one of the most interesting bodies in the search for extraterrestrial life. Titan is thought to possibly harbor conditions that could support life, or at least prebiotic chemical processes similar to those that may have occurred on early Earth. Scientists have even speculated that Titan's liquid methane seas could offer clues to the development of life in environments vastly different from Earth's. Saturn's rings, which are made up of a complex mixture of ice and rock particles, vary in size and shape, with gaps and divisions that make them visually stunning. These rings extend far beyond the planet itself, but their material is confined to a relatively narrow band, only about 10 meters thick in some places. Uranus, the tilted planet Uranus, the seventh planet from the Sun, stands out as one of the most fascinating and unusual planets in our solar system. Classified as an ice giant, Uranus is primarily composed of a mixture of water, ammonia, and methane. These substances, along with other elements like hydrogen and helium, make up the planet's atmosphere and internal structure. Uranus has a diameter of approximately 50,724 kilometers, making it the third largest planet in terms of diameter in the solar system, after Jupiter and Saturn. What makes Uranus especially unique is its extreme axial tilt. Unlike most planets in the solar system, which have relatively upright axes of rotation, Uranus is tilted at an astonishing 98 degrees. This means that Uranus essentially rolls around the Sun on its side, with its poles pointing almost directly at the Sun. This extreme tilt is likely the result of a massive collision with another celestial body long ago, which may have altered its rotational axis. Uranus is also home to 27 known moons, with names such as Miranda, Ariel, Umbriel, Titania, and Oberon, all of which are named after characters from Shakespearean works. In addition to its moons, Uranus has a faint system of rings, composed of dark, narrow bands of rock and ice particles. Although these rings are less prominent than those of Saturn, they remain an intriguing feature of the planet's atmosphere. The planet's striking blue-green color is a result of the presence of methane gas in its atmosphere. Methane absorbs red light from the Sun and reflects blue and green light, giving Uranus its distinctive hue. The planet's atmosphere also contains trace amounts of hydrogen, helium, and other gases, contributing to its overall composition. Uranus has a long orbit, taking approximately 17.24 Earth years to complete one revolution around the Sun. Neptune, the windy world Neptune, is the eighth and most distant planet from the Sun in our solar system, located approximately 4.5 billion kilometers away. It is classified as an ice giant, a type of planet composed primarily of water, ammonia, and methane, which gives it a distinctive and vivid blue color. With a diameter of around 49,244 kilometers, Neptune is about 4 times the diameter of Earth, making it the smallest of the gas giants, but still a colossal world in its own right. The deep, blue hue that characterizes Neptune's appearance is mainly due to the presence of methane in its atmosphere, which absorbs red light and reflects blue light back into space. Neptune is accompanied by 14 known moons, with the largest and most famous being Triton. Triton is a fascinating moon because it orbits Neptune in a retrograde motion, meaning it moves in the opposite direction of the planet's rotation. This unusual orbit suggests that Triton may have been captured by Neptune's gravity rather than forming alongside it. The surface of Triton is also intriguing, with geysers that shoot icy plumes into space, hinting at the possibility of a subsurface ocean. The atmosphere of Neptune is dominated by fierce winds, some of the fastest in the entire solar system.